Let's zoom out and take a grand tour of our solar system, a vast, bustling neighborhood in the cosmos, teeming with more than just the familiar planets we learned about in school. It's not just the sun and 8 planets that call this place home, but also a host of hidden worlds that lie far beyond, waiting to be discovered. Beyond the swirling storms of Jupiter and the majestic rings of Saturn, there exists a remarkable class of objects that rarely make the headlines: dwarf planets, the unsung heroes of our cosmic neighborhood. These aren't just ordinary space rocks drifting in the void, they're fascinating worlds in their own right, with complex geology, thin atmospheres, and even their own tiny moons orbiting them. But what exactly makes a planet a planet? It all comes down to gravity, and the ability to dominate its surroundings. True planets have enough gravitational pull to clear their orbits, sweeping away debris and asserting their dominance in the solar system. Dwarf planets, on the other hand, are round-like planets, but they share their orbital space with countless other objects, unable to clear the neighborhood around them. Imagine a planet as the boss of its orbit, ruling alone, while a dwarf planet is more like a notable resident in a bustling, crowded neighborhood, sharing space with many neighbors. Take Pluto, for example. Once celebrated as our 9th planet, Pluto now resides in the Kuiper Belt, a distant region teeming with icy bodies and mysterious objects. Pluto is the king of this region, the largest and most famous, but it hasn't managed to clear its path of other icy neighbors. That's why, after much debate, it was reclassified as a dwarf planet, a decision that sparked curiosity and controversy around the world. But this isn't a demotion for Pluto or the others. It's the beginning of a new chapter in our understanding of the solar system. Dwarf planets act as a bridge between the giant planets and the smaller asteroids, revealing the messy, dynamic, and ever-changing nature of our solar system. They force us to rethink what a world can be, challenging our definitions and expanding our imagination. Our solar system isn't a neat, orderly lineup. It's a crowded, complex place, full of surprises and hidden wonders. Dwarf planets showcase the incredible diversity of worlds that exist, each with its own story and secrets to tell. They're not just oddities, they're vital clues to how planets form and evolve, offering a window into the early days of our solar system. These hidden worlds expand our cosmic perspective, reminding us how much there is still to learn. Science thrives on challenging old definitions and venturing into the unknown, always pushing the boundaries of what we know. The more we look, the more we discover, each new find reshaping our understanding of the universe. Dwarf planets are living proof that the solar system is full of surprises, with mysteries waiting to be unraveled. They're not just cosmic leftovers, they're essential pieces of the puzzle, helping us complete the picture of our solar system's history. So, let's give these underdogs their well-deserved moment in the spotlight, celebrating their unique place in our cosmic story. The story of our solar system isn't complete without them. Each one adds depth and richness to the tale. And that's what makes exploring space so endlessly exciting. There's always more to discover, and always new heroes waiting to be found. Who decides what counts as a planet? It's a question that sparked debates for centuries, from ancient stargazers to modern scientists. That's the job of the International Astronomical Union, or IAU, a global organization of astronomers who set the official rules for naming and classifying objects in space. In 2006, astronomers faced a dilemma. New discoveries in the Kuiper Belt, a distant region filled with icy bodies, revealed objects like Eris that rivaled Pluto in size and characteristics. If every large object was called a planet, our solar system would suddenly have dozens, maybe even hundreds of planets. The IAU realized they needed a clear scientific definition, so they set 3 rules. First, a planet must orbit the sun. Second, it must be round, shaped by its own gravity into a nearly perfect sphere. And third, it must clear its orbital neighborhood of other debris, dominating its path around the sun. The first 2 rules are pretty straightforward. No moons, no lumpy asteroids, only objects that are big enough to be round and orbit the sun directly. But the third rule, clearing the neighborhood, sparked intense controversy. It was this rule that led to Pluto's reclassification as a dwarf planet, a decision that shocked the world and divided astronomers. Dwarf planets like Pluto, Eris, and Ceres meet the first 2 criteria, but not the third. They're round and orbit the sun, but they haven't cleared their orbits. Instead, they share their orbital paths with other objects, unable to sweep away all the debris in their neighborhood. This new category of dwarf planet helped astronomers make sense of our increasingly crowded solar system, giving a place to objects that didn't quite fit the old rules. Not everyone agreed with the IAU's decision. Many scientists, educators, and even the public still debate whether the rules are fair or if Pluto deserves to be called a planet. But for now, the IAU's definition stands. It gives us a framework to classify new discoveries and helps keep our cosmic catalog organized, even if it's not perfect. Science is always evolving, and so are our definitions. The rulebook isn't flawless, but it's a crucial starting point for understanding our place in the universe. The debate continues, but the IAU's rulebook helps us bring order to the chaos of the cosmos, guiding us as we explore further. As we make new discoveries, our definitions and textbooks will keep changing, reflecting the ever-evolving nature of science. The IAU's decision in 2006 was a turning point in astronomy, a moment that changed how we see our solar system forever. It's a reminder that even in science, the boundaries we draw can be blurry, and sometimes the answers aren't as clear-cut as we'd like. For now, this is how we make sense of our ever-expanding cosmic family, grouping planets, dwarf planets, and everything in between. And as we keep searching the skies, the quest to discover new worlds and redefine our place in the universe goes on. Let's start with the most famous dwarf planet, Pluto. For decades, Pluto was our ninth planet, the icy outlier at the edge. Its reclassification wasn't a demotion, it made Pluto the prototype for a new class of worlds. Pluto lives in the Kuiper Belt, a crowded region beyond Neptune. When New Horizons flew by in 2015, we saw mountains of water ice, nitrogen plains, and a thin, complex atmosphere. Pluto is geologically active with possible ice volcanoes. It has 5 moons. Charon, the largest, forms a binary system with Pluto. Their cosmic dance is unique in the solar system. The other moons, Styx, Nix, Kerberos, and Hydra, add to the mystery. Pluto's story shows how science evolves with new data. We thought it was a simple planet, but it's a dynamic, complex world. Its reclassification opened our eyes to the diversity of the outer solar system. Pluto reminds us that the universe is always more interesting than we expect. If Pluto is the OG, Eris is the troublemaker. Discovered in 2005, Eris is more massive than Pluto and forced astronomers to rethink what a planet is. Its discovery triggered the Great Planet debate and the IAU's new definition. Eris orbits far beyond Pluto in the scattered disk, taking 557 years to circle the Sun. It's icy, distant, and has a small moon, Dysnomia, which helped confirm its mass. Eris's existence proved the outer solar system is full of massive, planet-like objects. Named after the goddess of discord, Eris truly shook up astronomy. It shattered our tidy model of the solar system. Eris is a reminder that the universe loves to surprise us. Now, let's head closer to home, to the asteroid belt between Mars and Jupiter. Here, Ceres stands out as the only dwarf planet in the inner solar system. Discovered in 1801, Ceres was once called a planet, then an asteroid, and now a dwarf planet. It's round, orbits the Sun, but shares its space with millions of asteroids. Ceres is a mix of rock and ice, possibly with a subsurface ocean. NASA's Dawn mission revealed bright spots, likely salt deposits from briny water erupting to the surface. This hints at possible habitability. Ceres is a relic from the early solar system, a planetary embryo that never grew up. It bridges the gap between rocky planets and icy worlds. Ceres holds clues to our solar system's origins. It's a unique, mysterious world worth exploring. Beyond Pluto and Eris, the Kuiper Belt is home to a host of other fascinating dwarf planets, most notably Haumea and Makemake. These icy worlds drift in the distant reaches of our solar system, far beyond the familiar planets we know. Both Haumea and Makemake were discovered in the early 2000s, thanks to advances in powerful telescopes and dedicated astronomers scanning the night sky. Their discoveries highlight the incredible diversity and complexity of these distant worlds, each with its own unique characteristics. Haumea stands out immediately because of its unusual shape. It's stretched out like a squashed football, a result of spinning incredibly fast, completing a full rotation in just about 4 hours, much faster than most objects its size. Scientists believe Haumea's odd shape, along with its 2 moons and faint ring system, are the aftermath of a massive collision long ago. This ring was the first ever discovered around a Kuiper Belt object, making Haumea even more remarkable. Makemake, named after a creation deity from Easter Island mythology, is slightly smaller than Pluto, but shines brightly in the darkness. Its surface is covered in frozen methane, giving it a distinctive, icy appearance with a reddish tint. For many years, Makemake appeared to be traveling alone through space, but in 2015, astronomers made a surprising discovery: a tiny dark moon now known as MK2, quietly orbiting this distant dwarf planet. These discoveries remind us just how much remains hidden in the Kuiper Belt. Every new object found, every moon detected, adds another piece to the puzzle of our solar system's history. Haumea and Makemake are living proof that the outer solar system is full of surprises, with features and stories we never expected to find so far from the sun. Each of these dwarf planets has its own story, its own moons, and its own set of mysteries waiting to be unraveled by future explorers. They challenge our ideas of what a planet can be, expanding our understanding of the incredible variety of worlds that exist in our solar system. The more we look, the stranger and more fascinating these distant worlds become, revealing unexpected features and challenging our imagination. The Kuiper Belt is truly a treasure trove of discovery, filled with icy bodies and secrets waiting to be uncovered. And as our technology improves and our curiosity grows, we've only just begun to explore this mysterious frontier at the edge of our solar system. The 5 official dwarf planets are just the beginning. Astronomers suspect there are dozens, maybe hundreds more in the outer solar system. Objects like Gonggong, Quaoar, Sedna, and Orcus are strong candidates. Some have moons, rings, orbits that defy explanation. Sedna's orbit is so distant and strange it hints at the possible existence of a hidden giant, Planet 9. Confirming dwarf planet status is tough. These objects are faint and far away. We need better telescopes and clever techniques to measure their size and shape. Each new candidate could rewrite what we know about our solar system. The hunt for new worlds is far from over. So, why all the debate? The IAU's definition isn't as clear-cut as it seems. What counts as round enough depends on composition. Icy bodies round out smaller than rocky ones. Measuring distant objects is tricky. Estimates can be way off. Some astronomers argue for a simpler rule: if it's round, it's a planet. That would make Pluto, Eris, and many others planets again. The number of dwarf planets depends on definitions and data. Some say there could be hundreds, even thousands in the Kuiper Belt. The truth is, we don't know for sure. Science is messy, and that's okay. The debate keeps us searching, questioning, and learning. The universe doesn't fit neatly into our boxes, and that's what makes it fascinating. What does all this mean? Our solar system is more crowded and complex than we ever imagined. Dwarf planets have transformed our view of the outer solar system from empty to vibrant. They're time capsules, preserving the building blocks of planets. Missions like New Horizons and Dawn revealed active geology and possible subsurface oceans. New telescopes will find hundreds more distant worlds. Each discovery adds to the puzzle of how planetary systems form. The story of dwarf planets is about curiosity and exploration. There's so much left to discover, even in our own backyard. Out there, countless hidden worlds await, and our journey to reveal them is just beginning.